level of education, and that is ordinary. For example, you can say it is illiterate, college educated, or whatever it may be. So it can go like that. And nominal means we cannot order. For example, your color preference, or your skin color, or your religion, or your mother tongue. So these are the features belonging to the category nominal. Understood? So whether it is nominal or ordinal, we can manage successfully with the help of what I have illustrated. But the moment you have interval value data, your problem begins. Because here the set of possible values, the number of possible values assumed by what? I think they're waiting for my permission. Okay, so assumed by the features becomes uncountable, in other words, unmanageable. So I said you need an alternative method. Okay, now is there anyone who can give an alternative to this? I want one of you to tell me. I said when I have a data set like this, for example, when I have this urine data set, I have possible values are quite uncountable. You have 4.91, 5.14, etc., etc. But now I said because it takes unmanageable number of values, we need an alternative approach. Do you have, is there anything which is coming to your mind? Any of you who can tell me? Still we can continue with whatever I have told earlier. Understood? I do not know whether I have questioned properly. See, I said when we calculated those probabilities, prior probabilities, we considered the possible values. I said, writing first is yes or no. There are only two possibilities. Therefore, I can think of all possible combinations, etc., etc. Now, when the variable assumes uncountable number of values, I said you cannot proceed with this. But if at all there is someone who is willing to challenge me, no, I don't want to proceed like you. I have an alternative method. Is there anyone who can propose an alternative method? Any of you? Yes? I want one of you, however foolish it may be, the answer may not be fully correct. I want you to already explain, because one participant had a conversation with me during the lunch break, and he asked me about, I said, you should have asked that doubt in the session itself, so that you are benefited by it, so that others are also benefited. I want one of you to think, don't we have any other method? Yes? I want someone to tell me. Yes. Is there any participant or not? I am saying, you have, yes, I think somebody is trying to talk. How about you, do you have any suggestions, sir? Sir, madam, who are you?
Sir?
Yes, sir.
Sir, I am Suresh from Statistical.
Hi, Suresh.
Sir, suppose we have a mixed group of data.
Yeah, that question I would like to resolve later. Now let us stick to the point which I am trying to tell you. See, I am saying the values are something like 145.6, 134.8, and I have some 100 instances.
Okay.
I have values ranging from something like 140 to 180. Understood? So I have an uncountable number of values. I said when you have interval value of data like this, you have to stick to some Gaussian Bayesian or whatever it may be. Is it necessary? Or something comes to your mind? Apply your mind. Yes. Can
we normalize data?
Normalized means considering you have uncountable number of values. Now, let me not waste your time. You can think of your process called discretization. Understood? So, we can very well do discretization. See, I said we have one branch of research related to data science where we deal with a lot of pre-processing stages. So, pre-processing means you have to make your data fit for further analysis so that the conclusions which you draw out of your analysis are credible. Understood? So if you don't do proper pre-processing, the credibility of your findings will become questionable. Understood? So this discretization is one component of the pre-processing. That means a continuous, say, what is the opposite of discretization? Discrete opposite is the continuous. Understood? So what I am saying, you can form a kind of intervals. Understood? So you can have bins. Understood? That's what we mean. See, for example, when I suppose I have height as my feature, I am saying it can lie anywhere in between 140 centimeter and 180 centimeter. Of course, it has uncountable number of values. Understood? What I am trying to tell you, you can put 140 to 150 as one range. Whatever value you have here, we have put it as a short value. Understood? Height is a short height. Understood? So here you can have something like 150 to 1 centimeter as medium level of height. So 160 to 170 you can take as tall. Understood? And above 170 you can take as height. So in that way, you can always think of some alternative. And see, this is what we have to do in research. Understood? So what I am saying, you can think of a small problem like this. What I am trying to tell you, you can make your navigation classifiers. There are two approaches. One which we have seen, what I have done, I have illustrated using the cricket data set, comes under the category of categorical navigation. Categorical navigation. Now, I am saying you can go for Gaussian navigation. Understood? So I said you can go for Gaussian navigation if the feature happens to be a continuous feature. Understood? Okay, fine. I said Gaussian navigation you can think of very seriously only when you can validate your possible values. Understood? That means you have to satisfy your customer that your data, customer means what? You are a referee, paper referee or whole maybe. But nowadays, paper refereeing is also not done properly. If you pay some amount to the blindly publish whatever junk you say, let me not dig into those details. Then I'll show my anger that will result in unwanted conflict. So, I said Gaussian navigation application requires the validation. That means you have to satisfy either yourself or you have to satisfy the person who refers your paper that this assumption is valid. Also, when this assumption is valid, you have two approaches. Blindly use Gaussian navigation, whether it is valid or not. That you keep as one strategy. The other strategy is you convert your interval value data into categorical data. Understood? So let them fight with each other. So you try to do the prediction with the help of Gaussian navigation and try to predict using categorical navigation. Let us see who is going to win. Understood? How you are going to decide whether A is going to win or B is going to win. That we do with the help of some validity measures. That is what I told you. Always we have to see the quality of or results produced by your classifier. I do not know whether what I have told is sensible or not. Is there anyone who can just repeat what I said? Please remember, never I used to utter nonsense. Whatever I believe, like that. Understood? I may be wrong also. Understood? I want one of you to tell me or summarize the explanation or some input I have given, which is worth taking as a small research problem. I won't tell that once you do this, you'll get an Nobel Prize or a Nobel Prize. Understood? But at least a decent problem I have given you. Can you follow what I am trying to tell you or not? Is there anyone who can just repeat what I said? I tell you one small thing. When I teach for our MSc data science students, I used to reward them with 5 rupees or 10 rupees, or sometimes I have given 50 rupees also. Some of our colleagues know. For what? For not giving any solution. Just if they repeat what I have told them, understood? I used to reward them with some cash prize. Understood? Okay, today, now I will give you a cash prize. If you can answer to this one. Can you just, one of you tell me, we will give, we are very rich, so if I send 50 rupees or 100 rupees, it is not worth it. Understood? So all of us will congratulate you if you can repeat what I have told. Because I do not know whether really participants are present or not. There are 46 participants. I would like one of you to repeat what I said. Yes? Is there anyone who is willing to tell? Now, if you can tell, I can help you in doing further research in that, provided your guide permits you. If you are not going to include that in your PhD work, you can keep it as a separate paper. Is there anyone who can tell me what I have repeated? If nobody tells, the session will be closed at 2:15. I will not continue beyond 2:15. Yes.
Sir, good afternoon, sir.
Yes, sir.
Yes. Sir, later only I have joined, but I'll tell you what I have understood.
Yeah, very good, sir. May I know who you are, sir? Dr. Sundarajan, sir.
Dr. Sundar.
Sundar, have I seen you, sir, inside the campus?
No, sir. I am from outside of Tamil Nadu, sir. I belongs to Kerala.
Yeah, fine, sir.
I know about your profile and the things. That's why I have understood to attend this workshop.
Okay. You are from which university, sir?
APJ Abdul Kalam Technological University.
Oh, fine. Okay.
Affiliated institutions.
Okay.
That uncountable number of value between the interval, you have done a discretization in the categorical data.
Okay.
So that is what you have mentioned in the last 5 to 7 minutes.
Yes.
Then we have a Gaussian naive-Bayes method. So we have to evaluate these two techniques with this evaluation parameters. Which one is going to be?
Yeah,
that is what you have mentioned.
Yeah. So I will tell you, if not 100% perfect, because it is very difficult to satisfy me. People who normally interact with me, like the person Suresh, who is from Madras University, knows that I will never get satisfied. Anyway, I really appreciate that there is someone who is trying to follow me. It's very simple. See, when we have data like this, for example, when I take this particular range of, so I have some minimum and maximum values. See, this is what I told you in the lunch break. I have given you a small work. So here you can see those variables. For example, if you consider the Egyptian sky data, there are you have some. If you click this toggle details, you will get several statistics. So you get some quantitative statistics as well as descriptive statistics. So the minimum value happens to be 119 and the maximum value happens to be 148. So that measurement with that MB, I do not know what is that MB, that explanation I have given in my presentation. So what I can do now, you can have a kind of a partition like this. For example, anything which lies between 119, that minimum and the first quartile, can be called as a lower value. Understood? And between the first quartile and the second quartile, median, that can be taken as some kind of middle value. Understood? And something like in between 134 and 137, I can take as a higher value. And beyond that, I can call as a very high value. So these how many unique values? How many unique values I have here? I think somewhere I have seen. Yeah, the number of your distinct values happens to be 26. Understood? So those 26 values can be simply replaced by 3 or 4 values. See, whenever I say you take the minimum between minimum and 5th percentile 126. Minimum and 5th percentile 126 means it is very small. So let me have a look at my Egyptian sky data. So when I take this data, I will have a look at this one. So this 131. So when I take my 131, that fellow is going to be according to my output, what happens, see, please listen, this is something which is really worth it. So this 131 happens to be the first quartile value. So that, as per my recommendation, it is something lying between 136 and 131. I will call this as I will call this as very low value. This is very low. So I will replace that value by low. Understood? In the same way, I will take my 121. 121 I will call as very low. This is low, very low, and this is high. This is high. This is high. This is so something like that. So this 141 is very high. So these 26 values which are inside the particular interval can be simply replaced by 4 levels of a categorical variable called MB. Understood? So this is what I am saying as a discretization. So discretization means you group the values over different ranges. So once you do this kind of a conversion, automatically you can make use of the categorical naive Bayes. So use categorical naive Bayes and use Gaussian naive Bayes, whichever is working well. How do you know whichever is working well? You go for the precision or recall, FMS or whatever it may be. Based on that, you can start seeing. Understood? So if you have understood a little bit, be happy, else don't lose your heart. If you have any doubt, you can call me at any point of time. I'll be glad to help you out. Now, I don't want to spend much time on these things because if I start talking about these 10 lines, it will consume more than 2 to 3 hours. Understood? So, you try to move around, see what is the meaning of skewness, what is the meaning of kurtosis, understood? What is the meaning of coefficient variation, all those things, and what is this quantile statistics information. So all these things are very much needed. Before you start doing any analysis, you have to spend more time on these things. Otherwise, you will lose your credibility. Credibility means what? I mean, it's understood. So this is what I am trying to tell you. So now I said I am going to recommend Gaussian naive if my variable is a continuous variable. That means if it is an interval valued variable, then I can think of using Gaussian naive. Understood? Okay. Now let me just spend some time on this. Now you please listen. We use Gaussian naive. We use Gaussian naive when the features assume values over the intervals. Understood? Now, it implements Gaussian naive. It means what? This Gaussian NB is a function which is available in Python. So this Gaussian NB implements the Gaussian naive algorithm for classification. Okay. So, it assumes the likelihood of the features is this one. Understood? We don't call this as a probability. We don't call this probability. There is a misconception about probability density functions and the probability mass functions. In fact, some of your even people who teach statistics regularly also sometimes they overlook the difference. Understood? See, if you consider the variables, I don't want to use the word random variable to frighten you. If you have interval valued values, interval valued features, understood? We define what are called continuous variables. Understood? And if you have discretized values like 0, 1, 2, 3, not necessarily integers, it can be even fractions also, 0, half, 1 by 3, 1 by 4, etc. So if you have a set of countable number of values, then it is called discrete. Understood? So the probabilistic properties of a discrete random variable or a discrete variable is explained through probability mass function. When you have a continuous variable, we use the terminology probability density function. So probability density functions are related to continuous variables like your height, weight, whatever it may be. And this discrete quantities are related to countable number of values. So if you have a variable which can assume countable number of values, then that becomes a discrete and a variable. For example, you can ask me, okay, you have shown some data for us. Now, I have told you, Mayer division classifier is a highly criticized classifier. It is not normally recommended. After the introduction of things like support vector machines, etc., it has lost its charm. But still, it is finding use, particularly in text mining. Understood? So I will show you one data where you have an opportunity to come across the data. See, for example, here I have a small passage. Understood? I have given you. I think I have given a small. So here I have a set of. What is this? Yeah. So here I have one. I think I have it. So here I have a set of. I don't want to call them as documents. Some sentences, whatever it may be. Understood? So we have well done, good done, some nonsense I have typed just like that. Understood? So I have several phrases like this: a good work, great effort, nice work, excellent, weak, poor effort, not good, poor work, could have done better, etc., etc. Okay, now I can convert this data into discrete quantities like this. See, here I have produced what is known as term document frequency. See here, if you take a particular row here, the first row gives you how many times a keyword occurs. See here we have a lot of words like well, done. See, I think I have somewhere here. So we have a better, good, done, effort, excellent, good, etc. So these are the terms which are finding application in this definition. And here I have a count. Understood? So 0 means the particular word, this better never finds place. Understood? Good never finds place. This done finds place 2 times. So here you have one done, here you have another done. So when we have discrete count data like this, understood? So you have an opportunity to come across discrete data. The same way you can think of the number of accidents taking place. I don't want to give such examples for this gathering because here most of you are working in things like text mining or text classification, text clustering, whatever it may be. Understood? So these kind of data are called discrete data. So when we have a discrete data, we don't make use of probability the density functions because we use probability mass functions. So probability mass function will give you the probability of the variable assuming a particular value. Understood? See, for example, if I put like this, the probability of x is equal to x is 10cx into 0.5 for x or 0.4 for x into 0.6 for 10 minus x. If I find the probability of x is equal to 1, it gives you the probability your variable takes the value 1. Similarly, if I take probability of x is equal to 2, it will give you the probability that the variable x will take the value 2. So like this, the probabilities of the variable assuming a specific value can be obtained with the help of a probability as mass function. But the same thing cannot be extended for continuous variables. We cannot call the values assumed by a probability density function as probability. We don't call them as probabilities. It is a highly dangerous thing. See, for example, there are some audience who are familiar with the normal Gaussian density. 1 by sigma root 2 pi e power minus half x minus mu square. For example, suppose my mu happens to be 0 and mu happens to be 0. Understood? What will happen to my f of x? It will become 1 divided by sigma root 2 pi e power minus half x square. Understood? Let me find my f of 0. If I take my f of 0, I will be getting 1 by sigma root 2 pi. Now this quantity is not necessarily less than 1. For example, if I make 1 by sigma root 2 pi greater than 1, what happens? 1 by root 2 pi will be greater than sigma. So whenever sigma is less than 1 divided by root 2 pi, this quantity will become greater than 1. So we don't call them as probabilities. We call them as likelihood. Another simple example which I can give happens to be uniform distribution. Suppose we consider uniform over the interval 0, half. This is A and this is B. Your density function will be what? 1 divided by B minus A. That means 1 divided by half minus 0, which will become 2. So your density function, probability density function takes the value 2 for every value lying in between 0 and half. So we don't use the term probability. We call them as the likelihood. So that is the reason for calling this as the likelihood of the features. So the likelihood of the feature is assumed to be this one. So you just find 1 by root 2 pi sigma y square e power minus xi minus mu y square divided by 2 sigma y square. So this will be used for computing those prior probabilities. This will be used for computing the prior probabilities. I will repeat whatever I have told you. See, in the morning I said, if you have m classes, A1, A2, etc., AM or n classes, and B is your set of values assumed by the features. Understood? So B is the event of x1 assuming the value x1, x2 assuming the value x2, and xp assuming the value x2. Understood? I said you calculate the probability of A1 given B. Calculate the probability of A2 given B. Finally, calculate the probability of A and B and B. Now we will see among this which is maximum. Understood? So we don't calculate the entire probability, we just consider that proportionality. So we call this as K into the probability of A1 into the probability of B given A1. So this is the same constant K into the probability of A2 into the probability of B given A2. So like that, probability of AN into the probability of B given AN. So these quantities you have to calculate, understood? Then you go by the maximum. Okay, so when we had categorical values, we had no problem at all. But when we have interval value quantity, what we have to do? How do I calculate the probability of B given A1? How do I calculate the probability of B given A1? So the probability of B given A1 means the probability of x1 is equal to small x1, x2 is equal to small x2, etc. Xp is equal to small xp given A1. This is what I am going to calculate. So this I will be writing as probability of x1 is equal to x1 given A1 into the probability of x2 is equal to x2 given A1. Then finally probability of xp is equal to xp given A1. So these products I will get by assuming what is known as class conditional independence. We cannot simply ignore the conditional events. I don't want to go into those details. I am saying this you have to calculate by making use of this quantity. This 1 by root 2 pi. 1 divided by root 2 pi sigma A1 square. I'll tell you what is that. E4 minus half of sigma A1 square into x1 minus mu A1 square. The same thing I will be calculating for x2, x3, etc. etc. So you calculate this probability. I think it is becoming very boring because there is total silence here. Okay. I do not know whether you are able to follow or not. Just, is there anyone who can follow the head or tail? What happened to Korean members? Have they started sleeping? Okay, Vandana was again. Great. Madam, I will give you one small, I'll ask you a very small question. Let me take the same Egyptian style data. Okay. So, suppose I want to train my classifier by using the entire data. So, what happens now? My x1, please follow, I can tell you, it is very difficult to get persons who can explain this more clearly. Not out of arrogance, it is a fact, because I know what is the current status of teaching status. X3 equal to 89, X3 is equal to 89, X4 is equal to 49. So this is what I know. Now I want to know what is the probability, the class, what is the probability, what is the probability that time period happens to be minus 4,000 given this one. Okay, I want to calculate this problem. If I want to classify this, I said I have to calculate this probability. Now if I tell this is proportional, in other words, it is equal to some constant times the probability the time period happens to be minus 4,000 into the probability of x1 is equal to 131 given a time period is minus 4,000 into the probability of x2 is equal to 138 given minus 4,000 into the probability of x3 is equal to 89 given minus 4,000, probability of x4 is equal to 49 given minus 4,000. Do you agree with me or not? I want to calculate this probability. Am I right? Say yes or no. There is no silence, total silence from everyone. Yeah, I think two people are raising their hands. Muthalakshmi madam, please tell me. Muthalakshmi madam, Nisha, Antana, you understood or not? Okay. Yes? Okay, fine. Thank you, madam. So now so now for this data, when I have 5 classes, I am saying you have to calculate 5 such probabilities. See, one is for minus 4,000. The other is for the other time period. The other time period happens to be minus 3,300. So minus 3,300 into the same data. Similarly, the other period. So I have to calculate all the 5 probabilities. I will be putting that particular object into that instance into the class and corresponding to the maximum probability. Okay. Now, how I am going to do this? See, probability of minus 4,000. What I will do now, I will consider the number of cases in the training data set where I have minus 4,000 and I will be dividing it by the total number of cases. That means I will consider how many times my minus 4,000 comes. Now please listen, I can very well run the software and wind up in no time, but any fool can do. But the output produced could be understood only when you know the theory. So here you have this minus 4,000 comes 30 times. Similarly, minus 3,300 comes 30 times. So I have totally how many values? I have 150 values. So 30 divided by 150. So this 30 divided by 150. So this is something like the number of wins divided by the total number of matches. Am I right? Number of wins divided by total. Yeah. So I am really happy. Now here I have a problem. Now I cannot consider the cases where I have 131. I cannot consider the number of cases where I have 131. So if I try to calculate like that, I will become a fool. Understood? So it may appear only once. As a result of that, if you put 1 divided by 150, it may become 0. Understood? So we don't do that. What we do now, we find the likelihood. How do I find the likelihood? I'll consider those cases where I have my minus 4,000. I will find my mu y and I will find my sigma y. That means I will get what are called the maximum likelihood estimates of the mean and the standard deviation. See, I told you that the normal distribution, the Gaussian distribution, is characterized by 2 parameters. One is mu and the other one happens to be the standard deviation, x minus mu and square divided by sigma. So the sigma and the sigma. Only when you know the sigma and that mu y and the sigma y, you will be able to get this density. So what I will be doing now, we will be calculating that mu y and sigma y with the help of people who have statistics background will understand this one. Mu y I will be estimating like this. I will be considering 1 by n of a sum of all the feature values. So if I am worried about the first feature, I will be finding my x1 bar. So that means x1 bar where I have minus 4,000. See, you go for this minus 4,000. So you consider all these minus 4,000 cases, we calculate the mean. See, I just, if you want I can, but it is nonsense to go with the help of Excel, but still I want to make things fast. So I take average of this. Now I consider this, how many values? So I have minus 4,000. So up to this I will take. So I got my mean. So this is my, so this is my 131.3661. This I am going to show you in Python also. So this mu y will be 131.1667. Similarly, I will find sigma y. Sigma y hat will be, sigma y square hat will be 1 divided by n minus 1, sigma x1 bar minus x bar square. That means I will find the sample variance. So if I use the bar function, I will be getting this one. So I have with me, for example, I may have something like 10.66 or whatever it may be. So I will make use of this. What I will do now, whatever value, suppose I get mu y is 150.6 and sigma y is 10. I will put 1 divided by root of 150.6 into root of 2 pi into e power minus half into, you will look at here, 131. This value minus this 150.6 the whole square, and here I will have the 10 square. The same thing I will do for the second feature. That means I will go to the second column, I will consider the means corresponding to this minus 4,000. I will get a different mean and a different standard deviation. Understood? So I will calculate this probability. So keep on calculating these likelihoods. I don't want to use the word probability. Now, like this, you will be having how many 5 such likelihood probabilities. We have to put that particular object into that one corresponding to the maximum likelihood. So this is what I mean by admit. Yeah. Now, have you understood? Please respond. If you have any question,
Yes, sir.
definitely.
Yes, sir.
Madam, Vandana, madam, what is your background, madam?
Yes, sir. Computer applications, MCA, sir.
You are our KLU.
Yes, sir. This
Very
is
nice,
correct.
madam.
Part-time research.
Very nice, madam. Now, if we have really understood, I will say tell your IQ level is above average.
Yes, sir.
Because
Really, sir.
really understood, I am glad.
Yes, sir. Yes, sir. Yes, sir. You
But I want
explained very clearly, sir.
Okay, madam. But I want at least one of you to express the difficulty. See, when you have 40, I think, because I started asking questions, that 59 has become 40. Now, if I keep on asking questions, the rest also will run away. Understood? Okay. Anybody wants to ask? Gurpreet? Yes.
No, sir.
Have you understood what I told? Okay. Because personally, I know some of them. This Madam Anuradha is also familiar to me. I think she took machine learning. Have you understood Madam Anuradha, madam? Probably she is not in the meet. Okay. Fine. So if people are not willing to come out, let us proceed. So what I am going to do now, I am going to give you a simple demo using our Python. So once I complete that, I will be answering the query raised by Dr. Suresh. He was my colleague when I was working in Madras University. Okay, so now let me just show you. I hope all of you have that. I do not know which book I have used. Yeah, I think I have used. Yeah, I think I have used Navigation only. Yeah, let me not share. Yeah, Egyptian. Sorry, data. Understood. So, if you have installed Navigation, so you would like to try along with me, or you want me to just explain and go away? Please listen. Please respond at least for this.
Sir, we'll listen what you're saying, sir.
Okay, madam. Now, would you like to try practically or not?
Yes, sir. Parallelly, we will do practical also.
Yeah, that will be better. So what I will do now, all of you have Anaconda in your hand in the system? Say yes or no, madam?
We are listening.
So
Colab,
if you don't have Anaconda, what I suggest you to do now, you can go to Colab. Understood? So it needs no installation. You can straight away start working. Because as I was telling in the morning itself, it is not meaningful to proceed without doing things using a system. So I have just you go to Google and put Google Colab. So you should have Gmail account. I think you'll be laughing at me if I tell. So I go to Google Colab. You just receive this welcome to Collaboratory. You will be taken to this page. All of you please go to the page. Only if 2 or 3 of you respond positively, I will be proceeding to the next slide. So the moment you go to Colab, you'll be able to see a screen like this. That welcome message, and here I have, probably in your case, you may have empty startup, because all these things are available, because I have worked earlier. Have all of you started? So go to, so yes sir, opened. Okay madam. So what now, have you downloaded my Egyptian.csv file? Is it available with you? Yes madam. Downloaded, fine. Then what I suggest you to do now, do a very simple thing. See, because you are going to make use of the cloud, that server, Colab server for performing calculations. So if you are having Anaconda, things are very clear. What you can just proceed with only 2 lines. Import pandas as PD, df of PD dot read_CSV, the file name you give, it will automatically read. Now, in case you are going to use Colab, what I suggest you to do now, I will just forward you, I will put it in the chat box, certain things I want you to copy and paste. So, just you take these two things, just I will be putting in the chat box. I am putting in the chat box. There is my chat box. Here. Yeah. So go there, paste it, and remove those comments. The hash should be removed from and uploaded. So I just copy paste in your system. Yeah. So once you copy paste in your system, you should be able to get something like this. I will show you. Okay, so this also I will put it here. Okay, so we come up to this method. So now if you click this run command, you can see some movements taking place here, and you will be prompted to choose the files. Now we go up to this choose files. Only when you acknowledge, I will proceed further. So I must get this choose files, and this will keep revolving until you complete that selection. Choose files. What about Muthulakshmi madam? Are you getting that revolving circle? Yeah. Oh, okay, you are opening the Colab. Once you complete the reading process, I can go fast. Yes. Yes, sir. I open a copy the import file. Okay. So you have to select that file. So once you go there, you have to select. If you click this choose files, it will open up this dialog. You can choose Egyptian skull or whatever it may be. I think I have my Egyptian skull. So where is my Egyptian skull? I think I have Egyptian skull. It's in Joseph Sampa. Okay, let me choose from there. Let me go there. Users, C colon. You can go to that destination. Users, Sampa, date Egyptian.
Sir, on the data set இல்லையே சார், 4 data setல அது இல்லையே சார், அந்த எகிப்சியன்.
ஆமாங்க, அது வந்து
four data sets.
ஆமா, சாரி, நான் வந்து ஒன்றும் பெரிய பிரச்சனை இல்லை. வேணா
வேற டேட்டா செட்ஸ் யூஸ் பண்ணிக்கலாம்.
இது வேணா பண்ணலாம். பேர் மட்டும் கொஞ்சம் பார்த்துங்க. இல்லைன்னா நீங்க அனுப்பி விட்டுருங்க, ஒன்றும் பிரச்சனை இல்லைங்க. ஒன்றும் ப்ராப்ளம். ஆடா நீங்க இதை நான் மறந்தே போச்சு. நான் முதல்ல சொல்லிட்டு
ஏன்ட்டதான் இல்லையோ நினைச்சிட்டேன்.
இல்லை சாரி, நான் இல்லை நீங்க எந்த டேட்டா யூஸ் பண்ணிக்கலாம். பேங்க் வெப்சைட் கூட யூஸ் பண்ணிக்கலாம்.
ஓகே சார்.
இல்லை பேங்க் வெப்சைட் யூஸ் பண்ணிக்கலாமா?
ஓகே சார்.
அதே இருக்கு சார்.
ஏன்னா நம்ம டைம் வேஸ்ட் ஆகிட்டு பார்த்துட்டு இருந்தோம். So let us use bankruptcy. Data is going to. So what I will do now, I will once again rerun it. Choose file type, bankruptcy data. Desktop, FDP is one. I will take the bankruptcy data. That's all. Okay. So I will 100% done and on I hope now it is clear. Okay?
Okay, sir. Okay.
So then I will do this. So see here you have read that file. Now what we are going to do now, we are going to convert that into a data frame. So the CSV file which you have read will be converted into a data frame with the help of pd.read_CSV. The port example data frame on the cell. Understood? So let me just run this. You can see the output here. So now we have the output. The same thing will happen to this part also. Sorry, I think I am to be blamed. So we'll go there. Okay, I have changed the name of the file with it. You can please use bankruptcy data. Please use bankruptcy data. Okay. 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 Now, so I have up to this. So if I make it as a comment statement, I will not be able to see the output. I don't need that. Just I wanted to make sure that it is available. Here. Okay. If you call df.head, I get only the first 4 or 5 rows. Okay, so now I have come up to this. Okay, profiling I am not doing for want of time because the installation of profiling will take more time. Okay, so once I do that, see if I want to get a new cell, I have to just click this plus code. This plus text will help you to create comments and headers. So if you give plus code, it will help you to get your cell code. I hope I am making it clear. So here, what I will do now, I will take 0, 1, 2, 3, 4, and this is going to be my CL. I am slicing the features column. I am slicing the features column. I'm slicing the features column. Slicing the target. Target column. Slicing the target column. Okay. So I am slicing means what? I am just splitting. So WhatsApp message I am getting. Okay. Fine. Now you please paste this part also. I want at least 1 or 2 of you to approve this. Vandana madam, have you got it?
Yes, sir, I'm doing. I'm doing, sir.
Do and see whether you got this kind of output. I hope, since you are exposed to programming, I hope you know what I am trying to do here. If you need any explanation, please feel free to ask. Udit, are you comfortable?
Sir, I need the data file actually. I'm sorry, I didn't have that.
Why that bankruptcy you did not? I have put it in the group. It did not come to you.
No, sir. Maybe I missed it.
Then I will send it to you. Udit. What about Anaha? Do you have?
I think he also doesn't have, sir. We both need
No,
it.
then I will do one thing. I will put it in the group, in our group. Bankruptcy. Since I am using that, I will say it first. I hope you received it.
Received, sir.
Okay. I need the approval of at least one or two.
Yes, sir. Finished.
Okay. Now, it is very simple. Implementing a naive version in SQL is quite simple. So what I will do now, I have separated the data and the target. So next I am converting this Y into a one-dimensional array. That is an important requirement. Converting Y into a one-dimensional array. And converting this into a one-dimensional array. So towards that, what is this? Oh, because I have, see, this 150 came from Egyptian style data, but the data right now which I have has only 46. So this is going to be a 46. So there won't be any problem. So now, and put it in the third box. You can start using it. In case any of you require any help, please feel free to ask. Yes, Muthulakshmi, when you raise hands, I am unable to understand what is your intention. You understood or not? You have any doubt? Finished, sir. Very good, great. Fine. Okay. Right. Okay. So now I have completed this. Now you please listen. So having completed up to this, now I am going to get my machine ready for data. See, what do I do now? I can just explain. Suresh, are you comfortable?
Yes, sir. Yes, sir.
Okay. So here, what do I do now? See, here I am importing a function needed for performing Gaussian MD. So if you want to implement Gaussian neighbors, you have to import Gaussian MD from sklearn.neighbors. Understood? So sklearn is a very versatile library or package which we have in Python. Understood? So once you do that, I'll just separate this. Understood? So I'll just put it here. Now what do I do now? I keep my Gaussian NP function ready for the purpose of the classification. That so any more reference towards the classifier will be only via CLF, only via CLF. So that goes there. Understood? So then what do I do? Then see here in this part I don't have in this part I don't have any reference to the data set. So now if I want to make use of the data, if I want to train my classifier, what I will be doing, I will be proceeding like this. So I will just put it here, let me come here, let me paste it here. Now please listen, here we are importing the library. Here I am importing the library. Importing the library. Here I am importing the library. Okay, and here I keep the classifier under CLF. I keep the classifier under CLF. Now, have I made any reference to my data here in this cell? In this cell?
No, sir.
No, I have not made any reference. That means, at any point of time, you can keep on changing the training data set as well as the target. Understood? Now, if you have any intention of, or particularly if you want to do cross-validation and all, probably you have to use this classifier. So now when I have CLF.fit x, y, now only I am associating my, feature data set and feature column. Data set and feature column. Now, once I do that, I have completed the process of building the classifier. So that's all. So now it says it has completed this one. Probably I think I have not sent you in the chat box this particular part. So I am sending you this one. Okay. Now it's over. So then I would like to send this one. Okay. So I go to this part. I have gone up to this. Now I want all of you to come up to this. Then I will tell you what we have to do. Yes, finished, sir. Okay, answer. Nice. Okay. Yes. Now, so we have trained our classifier perfectly. So I have completed the process of training the classifier. But what I am going to do with this? That is an important question. So now I have to tell you what is the use of this one. Understood? Now please listen. Now, yes. If all of you are ready to listen to me, I will proceed further.
Yes, sir.
So now you please listen, madam. Now, so what is just let me recall my morning explanation. So what do I do here? So no, because I should not do like a robot. I should make things clear what I am trying to do. See, I said what are the things which we do when we consider classifiers? I said you make use of the training data set and come out with a classifier. That is what I have told you. Am I correct? So the classifiers are built using a training data set. So now I have created a classifier. Now you can ask me how the classifier works. See, the classifier makes use of those estimated probabilities. The probabilities which we have computed, like the P of A1, P of A2, everything is available here. Now I will tell you how to get those estimated probabilities. So some attributes are available for this one. So first let me tell you what are the attributes available here. Now you please listen. I have to be very, very careful here. So I have to give you this one. Now when I call this, I'm going to get, I'll just do one thing. I'll put one text. Understood? So what I will do now, I put as attributes. Now you can see here. Here you cannot type any code. So this is mainly for the purpose of attributes of the classifier. Attributes of the classifier. Now let me run this. Attributes of the classifier. Okay, fine. This is done. Why I am not able to minimize this? So, yeah. So attributes of the classifier. So first I would like to what is my plus? So let me go to this plus tool. Understood? So first let me tell the prior probabilities. That means the class probabilities. Understood? Estimating the class probabilities. You need not do anything. You need not do anything. It will do everything on its own. So if I ask for CLF dot class prior, I will be getting 0.45652174 and 0.5434. You got this value. Okay. How did I get this value? See, the data which I have used happens to be in my bankruptcy data set. Am I right? So this is what I have. So in the bankruptcy data set, we have, in how many cases? We have 0. 0 we have in 21 cases. So we have, in 21 cases we have 0. Out of how many cases? Out of 45, 46. So out of 46 cases. So here we have 46 cases here. Understood? So 21 divided by 46. So that value happens to be 0.4566. That is the value which we got here. That is the value which we got here. 0.4565 and this 0.5434. So this is your probability of A1 and this is your probability of A2. Have you understood? Please listen.
Yes, sir.
Now, what I am saying, this is only out of interest I am doing. But if you are going to be a practitioner, you need not bother about the attributes. Main use of your classifier is the prediction. How do we predict? How do we make use of the trained classifier for the purpose of a prediction? So if you are more interested, I can just give you that part, then I will come back to this. So I will do what is known as inline prediction. So I will be doing what is known as inline prediction. That means I will be predicting the classes of the objects which we have used for the purpose of our training. Okay, we will for the purpose of the training. So I will be going here. I will just put one plus 4. Okay. Now if I want to predict, inline prediction means what? How many objects do you have in the training set? Can you tell me? How many objects do you have in the training set? 46. Am I correct? How many objects do you have in the training set, madam? 46, no?
46, sir. Yes,
Yeah, I want to predict the classes of all the 46 objects which we have used for the purpose of our training. So that we can just do with the help of CLF dot predict. CLF dot predict of X. So CLF dot predict of X will give me the predicted classes. So this will give me the predicted classes. Okay.
Okay, sir.
I don't know whether your others are able to follow or not. So this is how we get the predicted classes. Okay, much more you can do. Now what I am saying now, for example, you may be interested in knowing whether this prediction is correct or not. For that, we found what is known as this part. We should have discussed while teaching validating metrics. But still, everything is integrated. We cannot separate one from another. Understood? Now, have you got up to this? Please, all of you, respond. Okay.
Yes, sir.
Now,
Yes, sir.
I have with me my actual data. So the actual data has, let me close this. I'm ready to close. Okay. Now let me, don't save. Now let me keep only this. So I have zeros coming for up to 22, and then you have 1 here. Now I want to know, I want to make a comparison of the predicted classes and the actual classes. Are you willing to listen? See, I am saying, see, I have predicted the classes. I have the predicted classes. If you want, I can call this system predict. Understood? So I'll call this system predicted classes. I have here my predicted classes. Then I will go for my printing. So then I can give print predicted classes. Predicted classes. Okay. So when I asked it to print, it is giving me predicted classes. Okay. Now, what I want to do now, I would like to see whether the classifications are correct or not. Now, please listen. Towards this, I would like to create what is known as a confusion matrix. I would like to create what is known as a confusion matrix. So, from here, scale-line.matrix. So, let us go together. Let me not separate this. From the scale-line.matrix, import confusion underscore matrix. So this is one advantage when we use collab. In Jupyter, it will be a silent thing. I think I have not given you in the chat box all these details. Just let me put it here. So you have the predicted class. Then I will go for my confusion matrix. So let me take this. Let me put it here. Let me go to that. Okay, so I have imported this confusion matrix method. So this function can be called to create the confusion matrix. So if I call confusion matrix, confusion underscore matrix of the actual class. The actual class happens to be y. See here itself you are getting y true values. And here you have predicted classes. Predicted classes. So once I call that, I will be able to get my confusion matrix like this. Have you understood? I will put it in. I will put it here and I will explain the meaning of this one shortly. So this is the most important thing which we use in all classifiers. Whenever you want to compare 2 or 3 classifiers, you will be using the elements of this confusion matrix. Okay. Have all of you got up to this? Okay, fine. Now we have come up to the confusion matrix. Now I want to do a small thing for to create a kind of interest among you. Now, please listen. What is this 18, 3 and 1 and 24? Can anyone of you explain? See, I have here 18, 3, 1 and 24. So this is what we have here. So this is my matrix. So the confused matrix is here. So this 18,3,124. Can anyone of you tell me what it is? See,
Sir, false positive, false negative, true positive.
So, if you have a look at exactly, so if you have a look at this data, so here you have 0 in how many cases? We have in 21 cases. Understood? So here we have 21. Understood? And here we have here we have another 25. Understood? So when I consider here, I have here actual. Actually, you have 0 here and 1 here. Understood? And here you have in the predicted class. So in the predicted, you have 0 here and 1 here. Understood? So I have here 0 and here I have 0, 1. Understood? So this is a good thing. That means, see, actually we have 21 instances. Among those 21 instances, see, what good it, you must be wondering why I avoid using the false positive and the false negative. No. Because when we do classification, we have multi-class problems. Like Egyptian spell data, we have 5 classes. Understood? So it is not proper to use the terminology true positive and false positive or false negative or whatever it may be. So I am a bit left. So here I have 25. So here I have 19 and here I have 27. What is this now? This is something which we don't want to happen. This is acceptable for us, and this also we don't like to have. Understood? So why I am saying like this now? See, originally we have 21 cases belonging to 0 class. Correct?
Yes, sir.
Among them, how many are predicted as 0 class? Only 18 are predicted as 0 class. And 3 of them are wrongly predicted. So that is a wrong prediction. So that is a wrong prediction. That is one kind of a mistake. And another thing is, 25 you have in one class. Among those only 24 are predicted correctly. Understood? Therefore, you have one wrong classification. So a matrix like this will help you to get scores like precision, recall, F-measure, etc. All those things. Now, before I proceed further, I would like to show you how we can create another small graph or a kind of what is known as a heat map for representing this confusion matrix. So we have a lot of libraries there. Now I would like to have one particular library called matplotlib. It is a very, very useful library. First I will show you. Yeah, let me go to the top. So let me insert one code there. I think I am inserting there. This I don't want to happen. Okay, so I would like to have somewhere here. So somewhere here I would like to have one addition. So it goes there. Now I will be giving somebody giving some message. They have to check whether they are trying to interact with me. So not audible. Now.
No, sir, not no.
Okay. So now let me create a beautiful plot like what is known as heat map, which will be familiar. Matplotlib dot pyplot as PLT. So this is the library which you want to create for, which you want to use for creating the heat map. I'm going to create very easily. Understood. Now from sklearn.metrics, sklearn.metrics, I would like to import plot confusion matrix. So this is another component of the same library, plot confusion matrix. So what do we do now? I give plot underscore confusion matrix of, you have 3 components. One is CLF, other one is a training object, another one is test object. So once I do that, I will be able to get my plot clearly. So I will get plt.show. Now when I call my plt.show, I will be able to get my plot clearly. Understood? Yeah. The small warning you get, probably some small changes now they have made. Understood? So this is how you get what is known as a peak plot. Understood? You see the plot?
Yes, sir.
I'll just put it in the chat box so that we can have a feel. Now, the same thing if you have done for, what can I say, the Egyptian style data, it would have been much more appealing. So you have the predicted labels here and the actual labels there, whatever I could hold comes there. Now it has become 30. I think they have started leaving. Have all of you finished?
Yes, sir.
Okay. So you have any queries? So we have what I have done now. I have predicted. I have predicted the classes. Will you do this in practice?
Yes, sir. We are doing.
No. What I am asking you now, will you please follow my question carefully. You have a training data set. You have a target class. So using the training data set, you have trained the classifier. So now you have trained the classifier. Now you have predicted the classes of the instances which are there in the training data set alone. Am I correct?
Yes, sir. Yes,
So
sir.
is it the end of your study?
No, sir. No.
Yeah, what will you do? You will try to
You have
predict
to test it.
incoming objects. So
Yes, sir.
you
Yes,
should
sir.
know how to predict the classes of the incoming objects which are likely to enter your system in future. So now I am going to tell you how to do out of sample prediction. Understood? So that is very simple. So what you have to do now, you have to create a, so now I will put it here. Understood? Now, let me have one more cell here. I'll add it here. So I will. So this is I will make it as text one. Understood? So this is out of sample prediction. I will call this as predicting the classes of the instances which are not in the data set. Out of sample prediction. Okay. So now out of sample prediction, I want to tell you. Now what you have to do now, you have to create one test data set. So you create that as a two-dimensional data. So you call this as np.array. So I think already have with me the small test data set that I straight away use here. So now I will take here this data I will use. So I will take Control A, Control C. Let me go there. I will put it here. So I will put it here, Control D. But the only thing is I have to make sure that these values are meaningful values. See, what do I have for x1, x2, x3, x4? I have fractions. So it is nonsense to use such values. So I will use here something like minus 0.43, 1.1, 1.1, comma 0.98. So 0.98, something like 0.649. Okay, 0.649. So I have one data like this. and another data I would like to, another instance I would like to 0.127, comma, 0. Minus 1.128. Some values you can give, not necessarily one which I am doing. So then what do I do? I will take this as 0.991, 0.991, and I will take here minus 0.51. So I have created how many objects? I have created, let me just see whether it is a meaningful. I have created a 2-dimensional array with the help of lists, Python lists. Understood? So let me take this, let me run this, whether I have created correctly or not. So I think there is an invalid syntax. What is wrong here? Minus 0.127. What happened?
Sir, one comma. Yeah, and here, yeah.
Yeah. 0.43.
After this, sir. 0.98.
It is always, just let me check. Yeah, so it is correct. So now let me predict the class for the first data. So when I predict the class for the first data, I am getting 0, 0. So you don't worry about this warning. So here, because what happened now, we have not used the class labels. We have used zeros and ones. That is what the fellow says. Now if you want, you can use. So both of them belong to 0, 0 class. Understood? It is what we have. Okay?
Okay, sir.
Okay. So this is what we do here. So now let me take this. I will put it in the chat box also. We have not made it categorical. That is one small. Okay. So we have come up to outer sample prediction. Okay.
Yes, sir. Finished.
Okay. So now I am saying we have learned how to carry on Gaussian neighbors classification. Understood? Okay. Now you can ask me, where are those probabilities? All the things I can give you one by one. So the attributes of the classifier, you can get like this. So these are your class probabilities. So these are your class probabilities. Can you follow?
Yes, sir.
So these are your class probabilities. Then if you ask, I said, yeah, please listen. Now I have to give you some more idea. So now what I will do now? I will give you CLF theta. So if you ask that, I will be getting this many values. So what is this? Now you please listen. You should know these are the estimated mean values. So these are the estimated mean values. Estimated mean values. Estimated mean values. Obtained maximum likelihood estimation. We need not bother about this one. Maximum likelihood estimation. Maximum likelihood estimation. Okay, please listen. So I told you, you should know self. Please listen. You have 4 features, x1, x2, x3, x4, and you have classes 0, 0, 0, 0, and you have 1, 1, 1. Am I right? Yes or no?
Yes, sir.
So I said you will be calculating the likelihood by considering 1 by sigma y root 2 pi e to the power of minus 1 by 2 sigma y square into x minus mu y square. So you will have mu y for the first feature, second feature. In other words, not mu y is equal to 0. I'll call this as the predicted value. Second feature, third feature, and the fourth feature. So these four values we have. Similarly, for y is equal to 1. So for y is equal to 1, we will have one value for the first feature, one for the second feature, one for the third feature, one for the fourth feature. So how many values you have here? Here you have 4 values, and here you have 4 values. So those 8 values are given here. So minus 0.06. So these 4 values are the mean values of x1, x2, x3, x4 for 0 class. And these 4 values are mean values of x1, x2, x3, x4 for 1 class. Is it clear? Say yes or no.
Yes, sir.
Please listen. I can tell very frankly that it is very difficult to get persons who can give interpretations like this. But these are the things which we need. Understood? Much more we can do, but taking into account your maturity level, I don't want to bore you much. Understood? So I will put it here. The first row gives the mean values of the 4 features. 4 features for class 0. For the class 0. And the second row gives the mean values of the 4 features for class 1. Okay. Now just I'll send it to you, both of them. Control C. This is sent there. Similarly, I would like to send this also. So this comment also I would like to send, because in my opinion, it is like a treasure. Understood? If you want to read on your own, first of all, I am not saying I am a genius. You may not have the necessary background in mathematics and statistics. That is why I am spending so much out of sheer interest. Otherwise, I could have just prepared some presentations and ran away just like that. So here we have estimated the probabilities, and here we have this one. Now, another thing is, you should know how to get the standard deviations also. That also you can get here. Understood? So you can get, if I ask for sigma, I will be getting that value also. So I will go here, I will put one code, and here I am going to get the estimated standard deviations. Understood? So that we get by calling CLF.sigma. We'll get another matrix like this. Don't worry about that warning. Simply ignore. They are going to use, in future I will have to use var. I don't know if this var in my version it will be available or not. So if I ask for var, yeah, it is giving the var. So estimated variances. Because these softwares constantly they change. So the estimated variances are given here. I hope similar explanation towards through. Say we had 8 means. In the same way, we will have one set of sigma square y equal to 0, one sigma square y is equal to 1. So we will have 8 set of values. Have all of you understood?
Yes, sir.
Another madam, why you are keeping quiet? I wanted some interaction from you. Is she there or ran away? Simply logged in and She is not at all responding. This is the problem when we do online workshops like this, because out of compulsion they would have joined. Okay, completed. Hello madam, யாருமே பதிலே சொல்லும் ஒரு 3 பேர் தாங்க பேசுறாங்க, இது எல்லாருமே கம்முனே இருக்காங்க. நான் அப்புறம் நிறுத்திடுவேன் கிளாஸ் கம்மன் ரொம்ப பண்ணிக்கிறாங்க. ரொம்ப மோசங்க. ஆமா, சும்மா என்னத்துக்கு லாகின் ஆயிடுங்க. அப்புறமேட்டு அந்த போன ஒர்க் ஷாப்ல ஒரு 80 லூஸ்ல உட்கார வச்சிருக்கீங்க, அந்த மாதிரி தான் இருக்கீங்க. அடுத்த எவ்வளோ யூஸ் சத்தமே நம்ம 3 பேர் தான் அந்த வந்தனா மேடம், முத்துலட்சுமி மேடம் கை காட்டுறாங்க அப்பப்போ. ஓகே, இதே மாதிரி இருந்தாலும் நாளைக்கு கிளாஸ் எடுக்க மாட்டோம் சொல்லிட்டேங்க. ஓகே, ஆமாம், சும்மா வேல்யூ தெரியாமல் ஆக்சுவலி we will be surprised. It is some students come to the campus but they don't attend the class. எதுக்கு அவ்வளோ தூரம் மதுரையிலேருந்து வருவாங்க அவங்க? Understood, idiots. Because if you get things free, you will not know the value. That is a very simple reason. Yeah, so, but people are not asking doubts. See, that means what? If you simply keep first and get things executed, it is not over. Okay, anyway, let me not worry much, because once I start deviating, then some very arrogant and make unwanted statements. Okay, so this is what I wanted to tell you. Now, one more thing, which I think almost everything I have completed, but please listen. When I call that CLF dot get parameters, now these are the things associated with the function call. That also I want to give you a small explanation. See, please listen. So let me call this. When I call this, I am getting this one. You should know what it means. To be frank, in Tamil, அக்கு வேற ஆணி வேறையா பிச்சுட்டாங்க இந்த நேவிகேஷன் கிளாஸ் ஏரியா. அது எதுவுமே நான் ஆல்மோஸ்ட் வாசி கவர் பண்ண மாட்டேன். Now you please listen. When I call the CLF.get parameters, it gives you priors is equal to none. What it does now, when I call class priors, it gives 0.4565 and 0.5434. Now, if you don't want that part to be estimated, understood? You can give your own priors. Suppose you have some reason or to believe in the first population you have some proportion, in the second population you have some other proportion. Then you are free to give that as the input. And this var underscore smoothing is a very, 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 very important thing. Var underscore smoothing is meant for, I will give you kind of this thing also. What can I tell? A notes comment also, which I have typed, because typing that will take more time. Understood? So I will put it here in the chat box. Please use this. It will be definitely useful for you, because see, your job is not over today only. Most of you are going to become teachers. Understood? So you should make your students to know what is happening there. So I will give here. I will be giving here. So CLF dot var underscore smoothing. Understood? So now, are you willing to listen to me? Or say yes?
Yes, sir.
Now you please listen. One problem with the normal distribution is, most of the around the mean, will be around the mean. Because if you have a look at the normal curve, the curve will be like this. So the curve will be like this. So here you have mean. So roughly 65% of the values, will be in between mu minus sigma and mu plus sigma, and between mu minus 2 sigma to mu plus 2 sigma, we'll have roughly 95% of the values. And so that means most of the values will be concentrated around this mean. Understood? So the coverage from the mean will be defined by your sigma. Understood? So this sigma will come there. Now what they will do now? They will not just like that make use of the sigma which you get from the maximum likely destination. They will be adding a small constant so that the coverage can be increased slightly. Understood? Can you follow what I talk? Yeah, see, suppose the mean happens to be something like 50, understood, and sigma happens to be something like 5. Between 50 and between 50 and 55, we will have 65% of the values. Now we don't like to be so rigid. We will be adding a small constant so that we give wide spread for the values which are covered there. So towards that we add with every standard deviation a constant which if you want we can define. That constant is called the smoothing constant. So by default the smoothing constant value happens to be the one which I have quoted there. So the one which I have quoted there happens to be the smoothing constant value, namely 1 into 10 to the power of minus 9. It is almost like 0 only. Understood? Point not etc. But if you have reason to believe you have to give you a slightly bigger value, then you can do that. Because this kind of a smoothing we have to do in a navigation classification. In Gaussian navigation, it is not so important. But when you come for categorical navigation, smoothing is very important. Otherwise, you will have a lot of computational errors. Understood? So you have a lot of computational errors. What kind of computational errors we can get now? See, when I solved those problems, I have calculated those ratios. Understood? So we estimate those probabilities. Now, if some of those events have 0 probabilities, then the entire product will become 0. See, suppose the probability of female population is equal to low, even B happens to be 0. That means out of 10 cases, no case gives you the female population is low. Then when you try to multiply that particular factor here, the entire thing will become 0. So we have to prevent this. Towards that we do a kind of smoothing. That smoothing is called Laplacian smoothing or whatever it may be. So it goes like that. So if you are not going to ask any more doubts, I am not going to create any curiosity in your mind. Could it have any doubt? Say yes or no, could it?
Sir, smoothing, can you explain a little bit again the last part?
I will tell you one small thing. See, if you take, I will just give you one small example. I will see whether I have any connection. Yeah, see, we do, I will just give you, I think, get itself back. I think we can give okay. This is the Egyptian style data. This is okay. The Egypt plotter. That's why I wanted to generate some samples, multinomial difference, but not this one. 1 minute. I have. Yeah, it will be better if I give one simulation example. 1 minute. Just let me. Yeah, 1 minute. Still find out whether I can have any simulation. Step first. Start. Scaling. Yeah, I'm going to see whether I have any example to show you. I have scaling, no, not scaling, simulation. LPA, scaling, yeah, I think I have a simulation. Say, I don't want this. This I will run for uniform. This and not model. Okay, I'll just give you a small example I would like to give. So let me just put it here. So let me go to my simulation example. I'll take this particular part. Wait a minute. Just let me begin a new page, new notebook. So let me take this. Because if you keep on talking, it will not make any sense. Only when I give you some examples, you'll be able to understand. So I will call this as import NP. We import NP as NP. Okay. Now I would like to simulate 50, 1000. See, that means, see, when I ask this, so when I ask this X1, now when I ask this, I am getting these values. Have you understood? Can you follow or not? No, if you
Yes, sir.
if you would like to run in Collab, that is fine. So let me take this. Let me go here. I will take a new notebook because every time I have to connect them, just a minute. So I have a small issue in my. This is not a PC which I am using. It is called a Surface. Okay. So now let me run this. So when I run this, I am going to get this. Yeah. So it is going to print this one. It's taking a lot of time. Okay. So it is almost completing. Okay. So here, what it means now. See, when I call np.random.normal 50, I call this as 50, not 59. Let us have just 50. I want to simulate. That means I want to get 1000 values from a normal distribution with mean 50 and standard deviation 2. That is what I am saying. So I want to get from a distribution like this. The mean is 50 and the standard mu is 50 and the standard deviation is 2. That means between 50 and 52, you will have 65% of the values. And between 48, that means because sigma is 2, between 48 and 52, you will have 65% of the values. Between 46 and 54, you will have 95% of the values. That is what I am trying to tell you. Now, I will just do a small thing here. So I have simulated. Now I want to show you a small plot. What do I do now? I just take import matplotlib.pyplot as PLT. Okay. Then I would like to have PLT dot hist of PLT dot hist of X1. Understood? So then I will call this and I will call my PLT dot show. When I call my PLT dot show, you will see what happens. Where did I go? I cannot make any text. Okay, so this is what I am going to get. So you got a histogram like this. Now what I am going to do now, I will take the same thing. I will not use my X1. I will use X2. When I use my X2, I will not be using 50. I will be using 50, 10. That means I am making my standard deviation large. Now when I do like this, you can see if I create a histogram like this, when I create a histogram like this, you are going to see the same thing happening. Understood? Now can you see, I think here it is X2, 50, 10. Yeah, I think, yeah, so here you can see here. Now, please listen, here you have the value only up to 56, am I right? Yeah. Say yes, sir.
Yes, sir.
And here, if you have the values spreading large, because the spread becomes large when you have a sigma large. Understood? So if you increase further, you'll be able to get a wider coverage. So this is the impact of the standard deviation. So what happened? I had a 2 there, that the 2 was added with 8, so that became 10. So it is able to provide the wide coverage. But we don't add like this, we add something like 2.01. or something like that. So we want to accommodate wider values when we would like to calculate the likelihood. So that is the main reason for including the variance. Have you understood? So we will do.
Understood, sir.
No, if you use exactly the standard deviation which you get out of the maximum relative destination, you have become very rigid. So what you do? So you are trying to accommodate even a slightly higher value, so that you can give maximum spread. Maximum spread means what? Increased spread. I should not use the word maximum spread. You give wider chance for such values. I hope it's clear. Can you follow? Say yes or no.
Yes, sir.
Yes, sir.
Okay. So now I am saying I have completed everything related to Gaussian array-based classification. Understood? So as I have mentioned earlier, we have to do some few more models. Understood? So once we have come to this, the remaining models can be covered not just like that. Understood? See, if you go out and tell somebody has taken an array-based classification for 4 hours, 5 hours, definitely they will laugh. They will tell what is there in array-based. Understood? It is not like that. It is only out of ignorance they talk like that. So we have so many things. Now, the next one which I want to introduce happens to be the other variant, namely this one, namely multinomial name-based classification. Understood? So, how I am going to do that? That I will be telling you in next few minutes. Understood? Now, yeah, where is that? Categorization, classification, medicine, etc., bankruptcy data set. Yeah, so we have a different data. Yeah, decision trees. I don't know why I have given the categories of classification. Have I saved that? Morning you have shown, no?
Yes, sir.
Bank, urine, bankruptcy, Egyptian scholar, urine data, wine, no, categories of.
Categories.
This is categories, huh? But not the one which I was telling. Maybe there is
Version.
various versions I have mentioned. One categorical, இது முடிஞ்சதுன்னா சாரி இங்கே தான் வரணும் நினைக்கிறேன். So this is so I have covered Gaussian array-based classification. Now I would like to spend some time on multinomial neighboring. See, particularly this multinomial neighboring is useful not only in text mining, even in building recommended systems also. We use this multinomial neighboring. Understood? So now you please listen. Among this, Gaussian neighboring classification is related to interval value data. Gaussian neighboring classification is directly related with interval value data because the distribution, namely the normal distribution, is related to a continuous case. This multinomial is related to count data. Morning itself I have told you how we make use of term frequency data set. Understood? So you have several documents. You will see the occurrences of the keywords. Understood? So that you will be considering when you consider this multinomial navigation. Similarly, we have complement navigation. Complement navigation is almost similar to the multinomial navigation, but specifically this complement navigation is used when we have imbalanced data sets. Imbalanced data set means you may have a large data set where a very small portion will belong to one particular class. See, in the examples which we have given, there is no imbalance. Understood? Sometimes we will come across a data set consisting of 1,000 instances. Understood? The training data set itself. Among them, 850 of them may belong to one particular class, and the remaining 150 of them may belong to the second class. Understood? So, the percentage of the objects belonging to this particular class happens to be very small. Such data sets are called imbalanced data sets. So, if you would like to perform classification by making use of imbalanced data set, it is strongly recommended to use complement navigation. I will explain why we have to go for complement navigation. But to be frank, if you are a serious researcher, don't stop with complement navigation. There are special algorithms which are specifically meant for handling imbalanced data sets. See, we have an algorithm called the SMART. Understood? SMART is an algorithm which is specifically designed for our imbalanced data sets. In fact, 1 or 2 years back, one of my students, Dr. Suresh must be knowing, is from Jharkhand. His name is Abhay, that black shark. Now he is with one multinational company. Suresh, do you remember?
Jharkhand Payana, sir. Jharkhand.
Yeah, he's an excellent student. So this SMART is one classifier. He was, in fact, I have learned more details about this SMART only after having interaction with him. I did not initiate the topic. One fine evening he called me, sir, I wanted to have a discussion with you related to SMART. I said, I don't know what is that SMART. To be frank, at that time, I do not know even what is the imbalanced data set. It's not long back, only a few years back, year before last year or something like that. Then he said, no, sir, if you read, you will understand and you can help me out. Then I spent some time and I found it very, very interesting. Understood? So if you are looking for some area of research, for example, you can come make a comparison of the complement the neighbor Bayesian with this kind of algorithms, SMART. In fact, I told him you can have some different approaches also. There itself, I don't remember what I have suggested because I have a very poor memory. I gave some competitors which belong to the same category of algorithms like SMART. Understood? So you can. So for imbalanced data sets, we recommend the use of complementary navigation. So this is what I wanted to tell you. Now, you please listen. Let me go back to this one. When I consider my categories of classifiers, Gaussian, for what type of data? Uttaralakshmi madam, Gaussian navigation is meant for continuous or discrete? Yes. Tell me, madam. Gaussian navigation. If you cannot talk, you put it in the chat box. Is it meant for continuous or discrete? Oh, madam. Discrete. Continuous. That is what I said. When you have interval value, நம்ம என்ன டேட்டா நம்ம யூஸ் பண்ண நீங்க சும்மா டக்கு ஓகே நடிச்சுட்டீங்களா? So when you have that bankruptcy data, you have values lying over a given interval. That is this is the problem. You should know what you have in your hand. கையில் என்ன இருக்குன்னு தெரியுமோ, அது எந்த algorithm யூஸ் பண்ண போறோம்னு தெரியுமோ. So you should know what you have in your hand. You should know what type of algorithm you are planning to use. You have to check the suitability of the algorithm. All those things you have to deeply think. Understood? But see, that is why nowadays I don't agree for giving this kind of talks, because my wife was shouting at me. You will believe or not, you may not believe. Understood? I literally took nearly 10 days to organize this content. I see very, in fact, that is why I asked this boy, Gurpreet, to attend the lecture, because I want someone who can interact with me. இது வந்து ரொம்ப மனசு கஷ்டமா டிஸ்டன்ஸ் அப்படின்னா உண்மையாவே எனக்கு எதிர்கால குழப்பம் அப்படிங்கிற மாதிரி தான் ஆயிப்போச்சு கடைசியில். I used to tell almost anyway, sometimes I use in filthy language in the class. It is not something which is recommended, but my nature is like that. Understood? So if things go out of if the things are not going in the right direction, I get maximum anger. Understood? Probably Suresh also may not know. People who are with me in Loyola, they know about me. If you ask Prakash, he will tell you. Understood? I used to kick them out. Literally, I used to push boys outside the classroom. And such an arrogant fellow, I was known. Anyway, I am not saying you have to be like that. You have to be, if you do like that, you will be in jail. Today, if you access code, that's all, your career is gone. Okay, anyway, கொஞ்சம் வந்து நம்ம மைண்ட் அப்ளை பண்ணணுங்க. அதெல்லாம் காலையிலேருந்து சொல்கிறேன். எந்த அளவுக்கு பாரு, பாதி பேர் அந்த மீட்டிங்கே இருக்க மாட்டாங்க. நான் சொல்கிறேன் பாருங்களேன். See, physically, virtually there are some, no problem, madam. If I have hurt your feelings, no problem. பாருங்களேன் இந்த 26 hours தான், அவ்வளோதான். இந்த 34 பேர் அது வரும், பாதி பேர் ஏற்கனவே தாவி, இன்னும் கொஞ்சம் பேர் கிளம்பிடும். ஸோ ஐ ஜஸ்ட் ஸ்பெண்ட் few minutes. Just let me tell, okay, this multinomial is meant for categorical data. So what we will be doing now, we will be using a distribution called multinomial distribution, which is available there in the probability theory. So it is late evening, I do not want to trouble you much by giving those explanations. I would like to answer to one of the queries raised by Dr. Suresh. I think I request him to raise the query so that it can be listened by others. Yes. Dr. Suresh, yes.
Sir, suppose we have, input variable or features like a mixed type.
Yes.
Sir, mixed type, what type of classifier we can prefer?
So now Dr. Suresh is asking me, how do I proceed if I am very adamant in using neighboring classification? Okay, so here I hope you can see, I have shown you one data set called HSP data set. So it is a very popular data set which I use during the course of my teaching. So here we have several features. Understood? So this is, yes, HSP means always household survey data set. This is not a data set which I have constructed. It is a very popular data set available here. And here we have several features like sex, which happens to be binary, race, which happens to be nominal, because we cannot tell white is better than Hispanic, and Hispanic is better than African American, etc. Race. Then you have socioeconomic status. This happens to be categorical. In other words, it is ordinal, because you can order. Socioeconomic status is low, middle, high, etc. School type, I do not know whether we can call it as nominal or ordinal, because you have public and private. Because if we say tell public is inferior, then people will laugh at me. Okay, then we have the type of program we have done. And here they have the scores in 5 different subjects. So this is one example where we have data of mixed type. Suppose you have data which is, you do not know the socioeconomic status. You have seen that you would like to use this as a training data for the purpose of predicting socioeconomic status, given the scores and the other attributes values. How do you proceed? That is a very good question. See, one area of research is handling the mixed type of data. That is a problem considered both in clustering, that means in the unsupervised learning approach, as well as in the supervised learning approach. So handling mixed type data is always a challenging problem. So there is no ready-made solution for this one. But what I have suggested now, so see here, you can group the features. For example, I can group these 5 features, and I can come out with the likelihood function, which is based on something like a Gaussian estimation. And here I can come out with the probabilities based on what we can say, either a multinomial or independently distributed variance, etc. So what I am suggesting you to do now, suppose you have some setup like this. Suppose I have x1, x2 and x3. These are continuous or interval valued. And here I have x4 and x5. This happens to be categorical. What I am saying now, you go for the likelihood for each one of them. P of x1 given a, and P of x2 given a, and P of x3 given a. So here you can use the likelihood of x1, likelihood of x2, and the likelihood of x3. Then you can go here the multinomial structure or whatever it may be. So you will get some probabilities here. Now you should know how to combine them meaningfully. What I can say now, you can call this as some P0 and call this as some P1, and you can go for a convex combination of these two things. Alpha P0 into 1 minus alpha P1. This can be taken as a posterior probability that can be used for the purpose of deciding the classifier. It is only a rough idea I am giving. Now, how do we choose this alpha and 1 minus alpha? Everything we go in an optimum manner. That means you see whether the accuracy of your algorithm is high or not. For example, you can go for precision, recall, F measure, etc. You see for what combination of this alpha. Sometimes you may have even 3 different groups of features also. We can consider something like alpha 1 P0, alpha 2 P1 plus alpha 3 P2, etc. So you combine them, and you go for alpha 1, alpha 2, alpha 3. So that means the weightage you are going to give. For example, I can have something like 0.2 and 0.3 and 0.5. So for this particular combination, I may have some accuracy. So when that weightage differs, that is going to definitely impact your validity measures. So you have to see what combination it is going to work out here. So for that, you can use something like a genetic algorithm or any bio-inspired algorithm you can use for deciding all these things. I hope this is a wonderful question which you can think of considering. Understood? Any follow-up, Suresh?
Yes, sir. Yes, sir.
Another one is, suppose you are not very clear, you are not very happy about this, you have the mixtures of distributions. So you can consider a distribution which is a mixture of a discrete and a continuous. Understood? That probability you can use, or that likelihood you can use for computing the posterior probability. Okay?
Okay.
I hope I have answered to your question.
Yes, sir.
Okay.
Sir, one more question. It is my intuition only I asked the question.
Okay.
Okay, sir, you are using Gaussian naive-based classifier for a continuous scale data. But in statistics, we know that suppose we have a continuous scale data, we verify whether the data set come from a multi-rate normal.
Yeah, so that is a wonderful question. In fact, I wanted to address this. Please listen. I said you can use that Gaussian எல்லாம் போயிட்டு இருப்பாங்கன்னு நினைக்கிறேன். கிளாஸ்ல யாருமே இருக்க மாட்டாங்கன்னு நீங்க மட்டும் நானும் தான் இருப்பான்னு தெரியலையா?
இல்ல இருக்காங்க சார் ஒரு 35.
Sir, I am available, sir. I am watching.
Now we have 35 participants. See, in fact, Dr. Suresh is asking me, you said you compute the likelihood with the help of this 1 divided by sigma y root 2 pi e to the power of minus half sigma y square x minus mu y square. This is meaningful only when you have data coming from Gaussian.
Yes.
So if the data comes from some other distribution, it may come from exponential,
Yes.
it may come from Cauchy, it may come from Dirichlet distribution, etc. You have hundreds of distributions in statistics literature. So when the data comes from a different thing, definitely you have to change your approach. You should not use Gaussian function for estimating those parameters. Probably you have to change the method of estimation. Okay, so if you want to know how we can check whether normality is, in other words, the Gaussian property is satisfied or not. For that we have several tools. One tool is just injecting the histogram. That is a very primitive tool. That is not very good technology. But we have what is known as QQ plot. So you can go for QQ plot to check for the normality. In fact, I had a small snippet to illustrate a particular idea. See, for example, here you can see, I had a small problem today morning while I tried to create my histogram. Anyway, let me just create one data. I think, where is it? Variable smoothing, out of sample prediction, multinomial. I think somewhere here I have generated the sample from anyway, now please listen. You should know matplot.lib pyplot. Yeah, see here I think collaborative work. Understood? See, now you can create, I'll just give you one small example. So let me take this particular, I'll just take this particular part. Okay, now let me go to my collaborator. Understood? So where is the simulated part? Okay, so I have simulated here. What I will do now, I will just insert one cell here. Now I would like to tell you how to get a histogram. So, sorry, QQ plot. So for that, you have to use a library called statsmodels.api. Please listen. The statsmodels.api will be extensively used by Dr. Arun when he teaches lasso and ridge regression. Understood? So what do I do now? I would like to, I don't have any sample here. Already I have my exponent here. So I have my exponent here. So this is my exponent. So I will use this exponent. QQ plot. I will tell you what is a QQ plot in a minute's time. So when I run this expand, you can see here the plot will go like this. I hope it gives you without any problem. Yeah. So you can tell me why it is happening. I must have standardized. I took this and told it, let me go to the end, I take this, 1 minute. Don't get panic. This is, I take 0,1. If it is not 0,1, you can standardize. Okay, so let me standardize this. Let me come up with a plot like this. So when you have a plot like this, so that means you have a red line here. Now if all the points, that means theoretical sample context, tomorrow morning I'll tell you what is the meaning of these things. Somebody must have the mind. Understood? So if all the points go along this one, then definitely you can tell you have normality. So this is one approach. So let me just change my this thing. So instead of normal, let me take my exponential. So let me take my data points as I think we have to take the same thing I will take. I put it here. I think I have to put it here. Okay. So let me go here. Yeah. So now I am going to generate a sample from, not from a normal distribution. I would like to generate my sample from what is known as the exponential distribution. Okay. Let us see what happens. So when I consider this, it goes like that. This and all I can remove. Everything I can remove. Because I had a small problem I have to explore. But in Colab it is working. In my laptop also it is working. But unfortunately it is not working in this np.random not normal. So I will have one. So let me create a plot like this. So when I create a plot like this, you can see here, stop, I'm sorry. I must have taken, I must have taken this. I must have taken this. So take this, and I will call this, now you can see here. Now when you take this, we are going to get a curve. What happened? The section.
The double X.
So now it will go like this. So if this blue line, if the blue points go along with the red line, then you can understand that the normality is satisfied. Now if it goes like this, understood, normality is present. If there is a drift, that means if these points are not in line with the straight line, then you can tell it is not normal. So in the case, definitely you cannot use the maximum relative estimates based on the normal distribution. You have to change your to exponential. That is why I tell those who do research in computer science, particularly in machine learning, should have a strong understanding of statistics also. But unfortunately, except one or two participants, nobody is opening the mouth. That is a clear symptom that they have not applied their mind, or physically they are not present in the meet. Understood? I have to think twice before I continue tomorrow. Understood? How does the neighbors classify data? Now I am going to answer Divya P. Are you there, Madam Divya?
Yes, sir.
Okay. See, whenever we are trying to construct a classifier, we assume that the data is a pre-processed data. That means we have done all kinds of cleaning. Understood? Without doing cleaning, you should not begin the process of constructing a classifier. What you must have done now, you must have cleaned the data. Cleaning the data, or in other words, the pre-processing of the data has several components. One is at first identifying the missing values. Identifying the missing values and replacing it by proper substitutes. That is called imputation. Understood? So that is one thing. And identifying the outliers. Understood? Identifying the outliers. So like this, we have plenty of stages in data pre-processing. So you should not think about what to do when we have naive-Bayesian, what to do when you would like to use naive-Bayesian classifier when the values are missing. You should not go to the step at all. Correct? Understood? So that stage you should not enter. First of all, you must have gone for missing values. You have to think whether the missing value, how to account for the missing values. That is called imputation. There are several imputers available. Understood? So if time permits, I don't know whether you have time to cover all those things. So that you must have done before going for the classifier. Have you understood?
Yes, sir. Thank you, sir.
முதல்ல நீங்க வந்து அங்க முடிச்சிட்டு தான் நீங்க வரணும். அது இம்புட்டேஷன் வந்து நிறைய மெத்தட்ஸ் இருக்கு நம்ம கிட்ட. அந்த மெத்தட்ஸ் ஏதாவது யூஸ் பண்ணிக்க வேண்டியது.
Sure, sir. Sure. Thank you.
And anybody else? Any other doubts? Yes?
No, sir.
No doubts. So if there are no doubts, I would like, because I have to teach something meaningful. I have to tell you what is, because listening for 4 hours or 5 hours is not a simple task. Understood? I know your difficulty. So, Madam Manochitra, are you there, Madam? Manochitra, Madam, or Kalpana, Madam?
Yes, sir.
Madam, stop பண்ணிக்கலாங்களா?
Yes, sir.
சார்
நாளைக்கு கிளாஸ் வேணுமா வேணாமான்னு நீங்க எனக்கு மெயில் பண்ணிடுங்க. வேணாம்
சார்
ஓகேங்களா? எதுக்கு நம்ம சும்மா தொந்தரவு பண்ணிட்டு இருக்கோம்?
சம்பத் சார்
Yes, sir. Somebody is trying to.
Sambat, sir.
Yes, madam.
Krishnan, sir, question.
நீங்க பிரசன்ட் பண்ற ஸ்கிரீன் வந்து ரொம்ப சின்னதா இருக்கு. கொஞ்சம் ஜூம் பண்ணி காமிச்சீங்கன்னா இன்னும் கூட பெட்டரா.
நீங்க அப்பப்ப சொல்லிருந்தீங்கன்னா நான் அனுப்பி இருக்கேன். இப்போ என்ன நான் அடிச்ச கோடு தெரியலையா?
ஆமா சார், அந்த ஸ்கிரீனே வந்து மார்னிங் வந்து ஜூம்ல பாக்கும்போது ஃபுல் ஸ்கிரீன் நல்லா இருந்தது சார். பட் இப்போ பாக்கும்போது பாத்தீங்கன்னா அந்த மீன்ஸ் கூகுள் மீட்ல எல்லா
ஓஹோ அந்த ப்ராப்ளம் சொல்றீங்க.
ஆமா ஆமா. சோ இதுனா இன்னும் கொஞ்சம் கூட பெட்டரா
பெருசு பண்ணிருக்கலாம். அது எங்க உங்களுக்கு வந்து அந்த கோடு